Ladies and gentlemen, you're welcome in our class. Today we shall be trying to discuss on t-tests. We will have some theoretical perspectives on t-test. Then we'll move on to see how we can implement t-test in a statistical package, and that is SPSS. You will be with me, Mr. Eddie. You're welcome. Now, t-test is among of the tests which has a wide application in statistics. And to implement or to conduct t-test, we should have what we call a student t-statistic. So we have some formulas which are used to calculate or to compute the t-statistics, the means, sample variances, and the standard deviations. But our today's lecture is not concerned with how to compute the t-statistics and the means and variances, but just a simple overview of what is t-test, and how to conduct t-test in SPSS. So kindly follow me as we move on with the t-test. Maybe I can simply take you through on where we can apply t-test and some types of t-test and how are they applicable. So basically, we can use t-test in testing difference in means. That is the key point. That t-test is mostly used in finding difference in means. Now, the modality or the mean, the difference mean which we are looking for, is what differentiates the types of the t-test. Number one, as you can read from the slide, it says to test if the sample mean differs significantly from the hypothetical value of the population mean. That sometimes you may wish you have some population figures or values or sample values, and then you need to test if there is a significant difference in means from an hypothetical mean, from a predefined value. Think, for instance, you have your employees, you are paying them salaries, and then there are some claims, maybe from labor institutions and things like that, that you are underpaying your employees. Maybe the mean salary is different from the defined mean. So you may wish to test if there is any significant difference in means between what is being taken to be the hypothetical mean or the predefined mean and the actual values or the actual salary which you are paying your employees. So that is one type or one area where you can apply the t-test. The other area, you can test if there is any significant difference in means between two groups. Think, for instance, the same example, that you have your employees, you have hired some individuals working for you, and you are paying them salaries. Let's say you have two groups. You have teaching staff, let's say, and non-teaching staff. So if you wish to find out if there is significant difference in salaries between teaching staff and non-teaching staff, then t-test becomes the appropriate statistical technique to be employed in testing or in finding out whether there is significant difference in salaries or not. And the other area is that you can use t-test in testing significance of observed samples, correlation coefficients, and degradation coefficients. That when you are testing relations between variables or the effect of one variable on the other, with the correlation, it gives us the relationship between two variables if they are related, and they should be considered variables. Now, for you to conclude if the relationship exists or not, you should have the probability value, and then you test depending on the given level of significance. Now, t-test is much applicable in such areas. The other area where t-test can be applicable is in regression analysis. That when you're trying to find out the relationship, the effect of one variable on the other. Now, for you to conclude or to have the final conclusion whether variable A affects variable V or variable C has an effect on variable D, then we use t-test is the most applicable. So we shall see later on how to do all those when we move on. So in this lecture now, the purpose of this lecture is just to use t-test in comparing the mean value of two sets of variables. That's number one. Number two, to test whether significant difference exists or not between two groups or two variables. So the application of t-test that we have seen from this point here, from point 1, point 2, and point 3, gives us three different kinds or different types of t-tests. With this one, the first one, the first one gives us the type of test which is called one sample t-test. If you need to find out if there's significant difference in hypothetical mean, and the true population value, then that falls under the one sample t-test. And the second and the third gives us the other two types of t-test, that is independent sample t-test and the paired sample t-test. So these are the three types of t-tests. We have the independent sample, paired sample. Paired is also sometimes referred to be the dependent sample. So if you find dependent sample, don't be surprised. It is the same as paired. Independent sample and one sample. Now, for the purpose of this lecture, I will take you through the first one, the one sample t-test. What is it, and how to conduct one sample t-test in SPSS. Then the next coming lecture shall be on the dependent sample and then on the paired sample. So these are some clarifications regarding the one sample t-test. So with one sample t-test, as you have seen in the previous slide, it says we use one sample t-test in testing if there is any difference in mean between the population value or the sample mean and the predefined mean or the hypothetical mean. That is the area where one sample t-test is used. Now, in order for you to conclude if there is significant difference or there is no significant difference, you should have what we call the level of significance. In most cases, and by default, in most of the software SPSS inclusive, we normally use 5%, which is 0.05. Now, when to reject and when to reject. So if you find the p-value less than the calculated p-value, then you find that there is evidence that the mean difference from the absolute value exists. But if the associated the calculated p-value is different or is greater than the given level of significance, then there is no way you can reject the null hypothesis. Then you conclude that there is no difference from the hypothesized value and the sample value. We shall see this when we move on into the actual practice. And here are some examples in areas where t-test can be used, one sample t-test. For instance, if you need to find out the average waiting time in doctor's office is there on 1 hour, that, for instance, when you go to hospital, you need to see a doctor and you are in a queue. Yeah. So normally in doctor's room, it is one first come, first out. It's on first in, first out, first come, first served. So you know, to find out on average how many minutes, for instance, or how many hours that a person spends in doctor's room. Okay, so you may have your applied mean value, and then you collect some data, then you do an analysis to examine if the hypothesized mean or hypothesized time is either the same or different from the actual value. The average funds of that tax return is different from that figure, and some other examples you can see from the slides. So here, when you're conducting t-test, your data must meet some conditions. Okay. Today I will just explain to you the condition which must be satisfied for you to conduct one sample t-test. But in the next coming lectures, I will also show you how to test this condition, one condition after the other. Okay. Number one says the test variables, that's continuous, interval, or ratio. Okay. Now that is the first condition, that your variable must be continuous, and a continuous variable should be either interval or in ratio scale. That's number one, the most important condition, that your variable of interest must be continuous. If you have a categorical variable, then there's no way you can apply one sample t-test. Next, scores on the t-test variables are independent, that is independence of observations. Okay, that there is independence of observation, that there is no relation between the scores of the test variables. Okay, each and particular variable of your interest in your study or in your sample, the scores should be not depend on each other, they should not affect each other. For instance, when you speak of, I give an example of salaries, that you have employees, you are paying them salaries. So the amount which you are paying one person should not influence the amount the other one is getting. There should be no influence in salaries for one person and another. There should be no relationship. Now, if that assumption is violated, then you end up having inaccurate p-values. So there should be the independence of observations. Observation should not be dependent, that one person or one score of a single observation should not be related to the underscore of other observation. And then sample should be random, selected from the population. There should be no biases, and they should be normally distributed, the scores. Okay, this is the condition for normality. We shall see how to test for normality. And then we have homogeneity of variances, one also of the most important condition, and we shall see how to test this. And then there should be no outliers. If you have outliers, it means you are likely to affect your standard errors and the p-values. So these are some of the most important conditions that must be satisfied when you want to conduct t-test, whether one sample, independent, or paired. We shall see later on how to test these conditions using our software. But today I just will show the basics or the outline of how to move on with the t-test. So we proceed, and here just an example, illustration of how to move on. So first I will show you, we just go through the slides to see how to the procedures on conducting the t-test, and then we'll go into practice by using our software, which is SPSS, in conducting the t-test. So for instance, here's an example that think that we need the requirement to state whether employees' mean salary is different from USD 50,000. That you have employees, you have employed people, you are paying them salaries, and then you need to test if the mean difference in salary is different from $50. And we are using this data. It's available in SPSS, sample data. Okay, it's available in SPSS. Now, in the first place, you should know your hypothesis, that what are you actually testing. So our hypothesis, the hypothesis that the mean employee salary is not different from USD 50. In other words, is that the mean salary equal to USD 50,000. Okay. Now the alternative hypothesis, it means if this is the mean salary equal to 150. Now the alternative is that the mean salary is different from 150. This will be the alternative hypothesis, and it will be null hypothesis. So here is an example of data set. We shall see when we move to practice, and this is our variable of interest, employees salary. We have gender, birth of date, education level, job category, beginning salary, job time, previous experience, and minority. So we shall see this later on as we move on, but our variable of interest is salary. We need to test if this one significantly differs from USD 50. Here are the procedures in conducting a t-test using SPSS. That you simply go to open your SPSS, your data set, go to analyze, then from analyze move to compare means, then from compare means you move to one sample t-test. Okay, these are the first three procedures: analyze, compare means, then one sample t-test. So let me go back to find my data. I have my data somewhere here, employees data. Let me open. For data to come up, you can see proceed. So these are the first three procedures. Let me see if we have our data already. No, it's still opening. Okay, here it is coming. IBM statistics 2025. Let us wait for our data. We need to go step by step for you to understand what is happening or how to go about. I can see it is taking long. Okay, so then the next procedure. Okay, yes, let us come. Good. Here is our data set, and this is our data set. Yes, fine. Now here are the data. You have gender, the first variable, birth of date, education, job category, salary, this is the current salary, beginning salary, job time, previous experience, minority. You can see the variables, how they are being coded, and the variable view window. And our variable of interest is this one, salary, current salary. You see, this is the label. So we need to find out if current salary differs significantly from 50 USD. Now, because we have a single variable, and what is the first assumption? The first assumption was, let us see from assumption, a test variable must be continuous, or scale. So from our SPS right here, this is our test variable, beginning salary, is in dollar, and it's continuous. So we are okay with that one. Now let's go and see how to implement this in SPSS. We have our steps right here. So we go to analyze, then compare means. From compare means we go to one sample t-test. These are the first three procedures. So if I press OK, this will open up. We have our dialog box. Now next, let us see from our guideline. Our guideline says, upon clicking one sample t-test, the one sample t-test dialog box appears. Okay, so this is the dialog box which has come up after clicking the one sample t-test. You can see here it is. Now what follows? Let's go back to the guideline. The guideline says, one sample t-test dialog box, select dependent variable. Okay, select the dependent variable that you wish to test by clicking on it in the left hand pane of the one sample t-test dialog box. Then after selecting, click the arrow button to move the variable in the pane. Now our variable is what? It's salary. So we go back to our software. We have to select our variables. Now here are the variables. Our variable is current salary. Now if you don't see clear, if you have variables and you don't see your variable of interest, you can just right click and then select display variable names. You see we have the variable names right now. So this is the variable of interest, then we put it in the test variables. Then after putting this in test variables, what next? It says test value. So in this box we have 0, but it's a place where you can type our hypothetical mean. And in this case, our hypothetical mean is 50,000. This 50, yes, it is 50. So what's the guideline saying? So we put our hypothetical value right here. By default it is 0, so we put our 50 USD in this box. Then next, okay, next it says, upon clicking and writing the values, then we have to go to the option to set for the confidence intervals. Now by default, confidence interval is always 95% by default. So you can opt either to keep this or to change, okay, depending on the one you wish to have. So you can see from here, this is the default setting, it's 95. We can either decide to change or just to maintain that one. So if you go back to then you click on option, we have our confidence interval which is 95. So you can either change or maintain that. So for us, let's just keep that one 95. Then if we are done, then you can click OK. Now we have our outputs here in the output. So let's go back to the guide and see what it says. So after you have done SPSS output results, and here are the output, okay, the same as this. See, one sample t-test, one sample statistics, one sample test. Our guideline, what is saying, we have one sample statistics and one sample t-test. So how to interpret this? Because the issue is not only having the answers or the output, is how we can go about interpreting. So for clarity, I've just labeled the outputs as A up to G, A, B, C, D, E, F, G, then H. So we'll go through one after the other to see how we can move on with the interpreting our results. And here is where I can pay attention. So the first table, which is one sample, the first one, the one sample statistics, present the descriptive statistics of our estimation, and you can see we have a total number of how much? 474. The mean average salary is this much. This is the mean average salary. It means that on average, the employees are paid this much. Okay, from the data set here, our variable salary is this one. So the mean salary is how much? 34419.51. can even see from this. Now standard deviation is 17 and the standard error is that much. So the first table shows the total number of observations in the sample, the mean standard deviation, but also the standard error. Okay. Now let's move on and see. We have the t-statistic. T-statistic is this one. B is how much? Minus 19.816. Okay. That is the t-statistic. Next, we have the degrees of freedom. This one. It is 473. That is degrees of freedom. Okay. Now, why 473? We have 474 as number of observation, and the degree of freedom it is n, then you less 1 because you have only a single variable. So it will be 474 minus 1, which is 473. The other important thing, we have significance level. You can see it is 0.000, less than 0.001. Okay, in other words, so this is saying 0.0000. Okay. Now you can see our p-value is very significant. It is very significant. Okay, and it is two-tailed. So from there we have the mean difference. What does this mean? This figure here, it is 15580.432. Now this mean difference is the difference between the hypothesized mean or hypothetical mean, which was how much? 50,000 in our case, and the true mean. The true mean in this one, 34,575. So if you take this minus this one, the difference, sorry, minus 50, not minus this, minus 50, here is 50. If you take this minus 50, then you have this, the mean difference. I mean the difference between the test value and the true mean. It is this figure. Next, you have the confidence interval. For our differences, this is the lower confidence interval, and this is the upper confidence interval. Now these are the values. The other thing, maybe you can see why the mean is negative. Okay, why is it negative? Because the difference is taken by taking the true mean or the population value minus the our guessing value or hypothetical value, which is 50. So you can see this one is less than 50. That's why this value is negative. Number one, even the t-statistic is also negative. Okay, it got the effect of this. Now those are the outputs, and we have just seen how are they, like here, how they are. But the most important thing which I've left with is to draw conclusion, because the inch is not only having the results, is to draw some conclusion. Now what can we say from that result? So this is the conclusion, that what was the hypothesis? There is no mean difference, the null. Alternative, there is a difference. Now here the conclusion, okay, that since the calculated probability value, which is the p-value, is less than this much, because it was 0.00, meaning it is less than this figure here, we have no evidence in favor of the null hypothesis. Therefore, we reject. This is the most important part of these statements. Out of all these words, this is the most important part. We reject the null hypothesis. Now, if we reject the null hypothesis, what does it mean? We reject the hypothesis that the salary of the sample mean is equal to the hypothesis population mean salary, and conclude that here the conclusion, the mean salary is significantly different. From the average salary of the overall employees. That's the conclusion, because the null hypothesis said no difference in salary. Now, if we have no evidence in favor of that hypothesis, it means there is a difference in salary. So if there is a difference in salary, then we can conclude that sample mean salary significantly differs from the hypothetical mean salary. Now, based on the results, what can you infer? Here are the two important things: that there is a significant difference in mean salary between the sample and the overall employee population. Because why we are saying that there is a significant difference? Because of this p-value. Okay? We are saying there is a significant difference in mean salary between the sample and the overall employees population because of this p-value is significant. Now, how much is the difference then? Okay, it's not only the amount of difference, but how much is it? It says on average the salary of the employees is about this much less than the overall employees population on average. See, on average the salary is this much less than the overall average salary. Now that is how you can implement one sample t-test in SPSS, and this is how you can draw some conclusions. Thank you for listening. Next we shall be discussing on how to implement independent sample t-test. So join me in the next session for you to get the continuation of the t-test. Thank you.